Yes or no? Hello, am I audible?
Yes, sir.
Okay, so I mean, am I audible to only one of you? So
No, sir, it is audible to all of us.
because nobody is responding. I don't know. I mean, I need to remove them, and they will not get the attendance. Ayushi Priya, are you there? Aditya, Aditya. Okay, so I'm removing Aditya from this classroom. Ashad Raja,
Yes,
Monodama Hasda.
yes, sir. Hello.
Yeah, okay. Ashad, you have responded. I have noted. Monodama Hasda. Okay.
Yes, sir.
MD Hatasham.
Yes, sir.
Monica Nagar.
Yes, sir.
Neha Kumari.
Yes, sir.
Rajkumar Rana.
Yes, sir.
Yes, you have responded. Rani Rupam.
Yes, sir.
Rashmi Kumari. Rashmi Kumari.
Yes, sir.
Saubhagya Singh.
Yes, sir. Present.
Saubhagya Singh. Saubhagya Singh is not there, I think. Shikha Maji.
Yes, sir.
Shreya Kumari.
Yes, sir.
Sushila.
Yes, sir.
Tanisha Kumari. Tanisha Kumari. Vinod Kumar Rajat.
Yes,
Vishaka, are you there?
Yes, sir.
And Mustaq. Mustaq is not there. Okay, so I am again calling Aditya.
Yes, sir.
Okay. Uh, Saubhagya Singh. Okay, she is not there. So I'm removing here her. Tanisha. Tanisha is also not there. So I'm removing her. Okay. So today we are starting our class. So this is the register organization and internal RAN structure and program status word. So the register organization, as we have discussed, the 8051 microcontroller is nothing but the 8-bit microcontroller. So this 8-bit microcontroller is that means this microcontroller is having the data bus of 8-bit width. Okay, so the data bus is 8-bit wide. So there are the registers that are used for the storing temporarily some data. So that must be of 8 bits, because more than 8 bits we cannot store. Suppose 16-bit data is coming. So 8-bit register is not having the capacity to store the 16-bit data because it is only 8-bit wide, right? So in the microcontroller 8051, whatever we have focused on, this focuses on the 8-bit register, 8-bit microcontrollers. Okay, so the reason is the data bus is 8-bit wide. Okay, so there are some internal RAM structure, as we have seen that in the microcontroller. This is the on-chip RAM, on-chip ROM, timer, input-output line uh, passes are there, and transmission reception, that means the serial communication also be done by using this microcontroller. All are gathered in a single chip. Okay, we have discussed. So this single chip is used for the dedicated purpose use. Again, I am repeating this word. Okay, so you can see this. What are the registers are available in the microcontroller 8051? This is A and B CPU registers. Okay. In addition, there will be program counter and data pointer, flags and program status words, internal RAM, some special function registers, and 8-bit stack pointer. So this A and B, every function of these registers will be discussed later on. So the similarities between this program counter in 8051 and 8085, whatever you have learned in the earlier semester, that program counter stores the address, that address of the instruction that is to be executed just next. Okay, so if the currently if a program is suppose I'm just writing over it, sorry, yeah. So if a program, now it is suppose a program is there, so this program is executing, then the program counter value will be what? The program counter value will be this plus 1. Okay, that means the next location. Clear? So this program counter will store the value. I'm repeating once again that the program counter value will be the next instruction to be executed. Clear? Now flags and program status word. Oh, sorry, the data pointer. The data pointer is only 16-bit register that is used for the external data operation, external transfer operation basically, because you people know that the specification of RAM and ROM available in the 8051, that is limited. So in 8051, the RAM size is 128 bytes and ROM size is 4 kilobytes. So the as this is the 16-bit address are there. Okay, so what is the address range? That will be, if the address lines are 16-bit wide. Okay, so the total addressing range will be 2 to the power 16. That is equals to what? 2 to the power 16 means? Anybody can answer.
64 KB. Sir.
That is 64. Very good. 64 KB. Clear? Why 64 K? Because if we break this, it will come like 2 to the power 10 into 2 to the power 6. So 2 to the power 10 means 1024 actually. Okay. So this will become like 1K, and 2 to the power 6 means 64. So 64 into 1K, that means 64 KB. Okay. So the total microcontroller will be is able to address 64 kilobytes of address. But only 4 kilobytes ROM is available. Clear? So we can add another 60 KB ROM externally. Clear? Maximum. For a single 8051, we can add 60 kilobytes of ROM externally. So for this external external ROM, this data pointer will be used. We will see in the later on that what are the programs can be done by using this microcontroller data pointer. We'll be going to it. Okay. So this coming to the flag and program status word, flag register is nothing but you people have already learned in 8085 microprocessor that the flag register are the logical, after any logical or arithmetic operation, if any changes are there, that can be monitored by the flag register. Okay. The program status word, this program status word is nothing but that what are the status of the program that can be seen in the registers. Clear? An internal RAM is there. Internal RAM is of 128 bytes. So it can be also external RAM can be connected with this microcontroller, and some special function registers are there. Will be going to an 8-bit stack pointer. As you know, the stack pointer is used for the jump and call operation. Whenever some subroutine is called, that may be a interrupt subroutine, interrupt vector subroutine, or any call function or any jump function that can be used by the, that instructions are used by this stack pointer. Okay, clear? Any questions on this? Okay, so we'll be going to the application of, the specification of A and B CPU register. That A and B CPU registers are specifically that A and B. That means these two registers are used only for the multiplication and division operation. Okay, we'll be going to this. You can see that the accumulator register, that is nothing but used for many operation including addition, subtraction, integer multiplication, division, and other logical operation. Now, very important thing is the this A register is nothing but it acts as the accumulator. Okay, so the A register is also used for all data transfers between the 8051 and any external memory. Clear? Okay. Now, the A register is used for all the data transfer, any external memory will be going to. Okay. Now the B register is used with the A register for the multiplication and division operation. Okay. So A register has the many kind of work, but along with B register, it only can be used in the multiplication and division operation. There is no other function is there. Clear? Clear or not?
Yes, sir.
Clear.
Okay. So just you can see the program counter and data pointer. I'm just yeah. So the program counter, the first point you can see and program counter both are 16-bit. Now you can ask why, sir? You have told that data pointer is the only 16-bit register, but the program counter, the function of the program counter is what? The program counter stores the next instruction to be executed, as the name implies that program counter. That means it counts the program, right? And data pointer, that means that it points towards some data from a particular address. So whenever we are storing the program, I mean counting the program, our address to be counted. So address is how much? 16 bit. Okay. The data is 8 bit. So inside this 16 bit address, this 8 bit data is stored. Clear? So this 16 bit address that is stored into this program counter and data pointer. So this is 16 bit register. So simple. Okay. Now program counter and data pointer are used to hold the address of the memory. So it is already discussed, and program counter is used to hold the address of the next memory location which is to be executed. Understood? I have repeated it many times. Okay. Okay. So that
Yes, sir.
program counter, specifically that program counter is it doesn't have any internal address. Okay, but the data pointer is made up of two 8-bit registers named as data pointer high. This is data pointer high and this is data pointer low. Okay, so this data pointer high and data pointer low, these together, this will form a 16-bit register, but individually this DPH and DPL, these two are 8-bit registers. Now data DPTR or data pointer is used to hold the memory address for the internal and external code memory. That means the internal and external code memory. That means if the program length exceeds the 4 kilobytes of ROM means every program whatever we are writing that will be written in the ROM, and every data is stored into the RAM. Okay, data will be stored into the RAM and program will be stored into the ROM. But there are some issues. I mean, there are some mechanisms or there are some architectural techniques are available where we can use the RAM as a ROM. Okay, so the RAM can also be used as the storing of the program or code. Clear? Any questions?
Sir, when we use RAM as a room,
Yeah, this is a very good question. When do we use? So suppose your peripheral devices, your address, okay, address lines that are available in the microcontroller that is used for some other purpose. Okay, so that at a time you cannot connect RAM and ROM together. So what will be there? In ROM you cannot store data, right? Because in ROM it will be read-only memory. We cannot store data, right? We can only read, we cannot write. But in RAM we can read, also we can write. So if we connect a RAM and ROM parallelly, then what will happen? Then some extra IO lines will be engaged. But to reduce the engagement, we are telling that this particular RAM can be installed for the storing of data and program. Clear?
yes, sir.
Okay. So going to the next one. Okay. So the program status word. Now the program status word, uh, just a minute. Now do this quickly. Okay, so again going back to the thing, that program status word, as we have discussed, this program status word is a 8-bit register. So this program status word basically contains the four math flags, user program flag F0, and the register select bits RS1 and RS0. Okay, so the PSW register is a bit addressable, so all the flags can be set or reset by the programmer at will. So here, just like the flag registers available in the 8085 or 8086 microprocessor, that just it was a bit difference between the 8085 and 8086, because 8085 flag register was 8-bit wide, but in case of 8086 it was 16-bit wide. Among the 16 bits, there were totally some around 10 to 11 bits are available for the checking of flags, checking of the status of the program. So here also in the 8051, just like the 8085, here the flag register is also 8-bit wide. Okay, so this 8-bit wide microprocessor, microcontroller program status word, you can see that from the 0, that means this was the D1 bit. Just let me highlight on this. This is a D1 bit, and this is the this is the D0 bit, and this will be the D7 bit. Okay, so this is the 8-bit. Now from the second bit, you can see this the second bit is D1. This bit is ignored. Okay, other than this, all the 7 flags, 7 statuses can be seen. So among this, first of all, we are coming the first bit, that is a D0 bit, is the parity bit. So parity bit just checks the number of ones and number of zeros are available in the result. Okay, so the result is containing whether the, just a minute, yeah, so whether the number of ones are even or odd, that can be checked by this parity flag. Now what is the function of this overflow flag, this OV? This is the third bit, this one. Whenever in some arithmetic operation or time counting operation or counter operation, what happens if a certain limit of counting is given and slowly the counter is running away and it reaches the limit, then this timer will give a status that my count is completed. Okay, that means my limit is overflowed. So then this overflow flag will be set to 1, otherwise it will be 0. Now what is the function of this 4th bit and 5th bit? This RS1 and RS0 will be just coming after this, or in the next class we'll be discussing that what is the RS1 and RS0. That is nothing but register select RS, register select bits 1 and register select bit 0. Okay, this coming to the 6th one, that is F0 general purpose flag. When we will be discussing about the special function registers, we'll be going to this F0, what is the function of this, and this 7th and 8th bit, this is very much similar with the 8085, that is auxiliary carry and carry flag, auxiliary carry flag and carry flag. Now when auxiliary carry occurs, if any suppose 8-bit addition operation, for example, if there is any carries occurred in the lower nibble to the higher nibble, then what will happen? Some auxiliary carry will be carried forward. Okay, so then only if some carry or borrow occurs in any arithmetic operation in the lower nibble of the data, then this auxiliary carry flag will be set to 1. Otherwise, no auxiliary carry, that will be 0. If auxiliary carry occurs, then it will be 1. Same as the carry flag. if some in an arithmetic operation, if any carry or borrow occurs in the arithmetic operation, then it will be set to 1, and otherwise it will be set to 0 if no carry or borrow occurs. Clear? Any questions?
Sir, it is written there that a PSW register is bit addressable, so all the flags can be set or reset by the programmer at will. तो सर इसका मतलब क्या हुआ सर?
No. That means uh, suppose RS1 and RS0. Okay. So these are the register select bits. So this line doesn't mean that every bits can be set or reset. That means if carry occurs, then we cannot set it, because we are executing a the microcontroller executing a program, and as a result this carry flag or auxiliary carry flag or parity flag or even overflow flag that can be set, but the reset operation can be done by the programmer. In this case, in these 4 cases, carry flag, auxiliary carry flag, overflow flag and parity flag. But in case of register select bits, we can set or reset these bits. This bit is just made by, made 1 or 0 by the user only or by the programmer only. Okay, and this regarding this F0 will be not discussing here because it will be more complex. We'll be discussing it later on. Clear? So
Oh, okay, sir.
that means that doesn't mean that every bit is set or reset. That means these all the bits either set or reset or both set reset can be done by the programmer itself. Okay. Okay, so everyone have gave your attendance, so we are stopping our class. Okay, thank you.